Assalamu alaikum everyone. How are you guys? Uh, okay, what's that? Mensuration, inshallah, on Wednesday. How are you guys doing? Let's call it a day already. We just started. Okay, so let's start. We just a second. Walaikum assalam. My tomorrow's exam depends on the stream. Okay. Good luck, first of all. So, we are doing add maths, as you guys know. Sir, how many significant figures you have to write? Angles per radians, degree of recipes, and matrix, the other side is significant, so clear. Dekho, three significant figures, unless the question says otherwise. However, if it's an angle in degrees, which says, then it's correct to one decimal place. That's what it says on the question paper. I think it's pretty clear. So yeah, that's the answer to your question. Okay, what happened to your hair? Okay, if I had $1 for every time someone asked me that in the last couple of weeks, I think I've lost track. But I went for Umrah. Yes, I think someone's already answered it. Okay, thank you. Anyway, so let's start, shall we? So we had done equation of a circle. We had done some past paper questions as well. Let me see how many questions we solved. Yeah, we solved a handful of questions. Now, today what we're going to do is we are going to, so today we are going to do this concept called, okay, I don't know what that is. Today we're going to do this concept called intersecting circles, okay? So here we go. And by the way, I have uploaded a worksheet of intersecting circles. You guys can download it. It's a worksheet that there's not a lot of material on intersecting circles. The one that we have in the book is wrong. A lot of questions are incorrect. So it's a lot of questions that I've compiled from different books. Make sure to download it, and yeah, you can do it for practice. I will be solving some questions from that worksheet as well. Okay. This stream is probably going to be an hour and a half max, probably less than that. So what about non-recurring? Dekho, non-recurring है 58.69, so this would be 58.7. Yes, everything correct to three significant figures except for angles in degrees, which is to be correct to one decimal place. Okay, simple as that. So this concept is called intersecting circles. Now this concept is unique to add maths, although we have coordinate geometry of the circle in AS Math. That's where I get most of the practice material from as well. But this concept, intersecting circles, is just unique to add maths. Now today's date is the 2nd of December 2024. Okay. Where is your hair? Okay, can please someone answer that on my behalf? Now, two circles, just so you guys know, two circles can either intersect. Okay, so here we can see two circles intersecting. It's possible that two circles just touch. Okay, it's possible that two circles do not intersect, which means we could be in a situation like this, or it's possible that two circles do not intersect when they are something like this. Okay, so non-intersecting, there are two ways circles cannot intersect, there are two ways circles can touch, and there's only one way circles can intersect. Okay, so let's go over it one more time. So here is one way circles don't intersect, here is another way circles don't intersect. Now, here is one way that circles touch, and here is another way that circles can touch. Okay, so that's what we're going to do. We're going to find out what are the possibilities, or how do we identify whether the circles are going to touch, intersect, or not touch at all. Okay, so the first rule, let's talk about non-intersecting circles. Okay, non-intersecting circles. So there are two possibilities. Let's say we have one big circle and we have one small circle. Now I'm going to be using some terms, so I want you guys to pay close attention. C1 is the center of circle 1, and C2 I will refer to as the center of circle 2. Okay? So let's say we join these 2 points with the help of a straight line. Okay, let's say I join these 2 points with the help of a straight line. So here's how this works. The radius of this circle, as you can see, is the radius of the big circle is R1. The radius of the small circle, as you can see, is R2. Okay, I'll make a dotted line so you can see. Here it is, and here it is. Okay, so these circles, clearly we can see they're not intersecting. Now, how do we identify without actually drawing it? How do we identify that the 2 circles will not intersect? So for that, let's write down an important note. So here's an important note. Let's write it down. If, and this, by the way, in case you guys are taking notes alongside, this is part A. Now, I don't use note-wise. I use good notes. Okay. If the distance between the centers, is greater than the sum of the radii, if the distance between the centers is greater than the sum of the radii, then the circles do not intersect. Okay, so that means C1, C2, the distance between the center, you can see, is clearly greater than R1 plus R2. Okay, so long story short, if the distance between the 2 centers is greater than the sum of the radii, then we say the circles do not intersect. Okay, did I miss anything? Sir, I can watch A-level. No, I don't recommend that. I don't recommend that you watch A-level functions for AdMaths. A-level functions is quite different compared to AdMaths. Anyway, so here's one way you can see that the 2 circles are not intersecting. Now, what's the other way? Here's the other way. That if one circle lies inside the other circle, then also the 2 circles do not intersect. Okay, so I'm going to color code this and make it easy for you guys. So if let's say we have the following. Okay, this is a little tricky. Okay, so let's say the smaller circle has center C1, and let's say the bigger circle has center C2. So let me color code it, make it easy for you guys. Now here you can see this is the distance between the 2 centers, okay? And if we talk about the radii, so let's go back to the color green. So this is the radius, let's call this R1, radius of the small circle, and then this is the radius of the bigger circle. Now here, if let's say I take the difference between the 2 radii, okay, if let's say I take the difference between the 2 radii, that is whether I do, if I'm doing, by the way, if I'm doing R1 minus R2, okay, then we'll take the modulus of it, okay, as in we only want the value without the negative sign, okay. So that distance will be greater than the distance between the 2 centers, okay. So if I take the difference of the radii, that difference will be greater than the distance between the 2 centers. Or in other words, here's how you can think about it. The distance between the 2 centers, as you can see, is much lesser compared to the difference of the radii, Okay, so these are some rules that you have to remember. If you can make sense of them, that's great. If not, then I would suggest that you simply memorize them. Okay, no two ways about it. So I'll write this down. If the distance between the centers, if the distance between the centers is less than the difference between the two radii. Okay, radii, in case you're wondering, is the plural of radius. Okay, then the circles do not intersect. Then the circles do not intersect. Okay, so long story short, if C1, C2, that is the difference, that is the distance between the two centers, is less than R1 minus R2. And whenever we're taking R1 minus R2, we ignore the minus sign. That's what the modulus is for. Okay, just like when you're calculating area, if you're using that formula, the matrix formula, you ignore the minus sign. Okay, so here also, you ignore the minus sign. So the conclusion is that the circles do not intersect. Now, this may all seem a little overwhelming, but we will when we're doing example questions, you guys will see how it works. Acha, what's that, sir? What was the last school? Nixer O levels. That was the last school I taught in. Okay, now let's talk about circles that are touching. Okay, or in other words, circles that are tangent. So there are two ways that two circles can be tangent. Let's write them down. Touching circles. Rejoin. Ali, you're from Nixer, right? If I remember correctly. So here's one circle. I'm quite happy with the decisions that I've made in my life. Okay, so here are two circles, and we can see, as you can see, that they're touching. Now, how do we decide, how do we check whether, using the center and the radius, whether the circles are touching? Let's write them down. Okay, so let's change this to the color red. Say here's C1, and here is C2. Okay, now the distance between these two circles, as you can see, is equal to the sum of the radii. So here's R1 and here is R2. So as you can see, let's write it down. If the distance between the centers is the same as the sum of the radii, the circles touch. Okay. All right. So if, yeah, this topic, although mostly I would say this topic is going to come in paper 1. So let's write this down. Let's summarize it. If AB is equal, sorry, not AB, C1, C2. If C1, C2 is equal to R1 plus R2, the circles touch. Okay, now there is another scenario that the two circles can touch, which is pretty straightforward. Let's write that down also. That is when you have one circle inside of the other circle, something like this. Okay, so here, very similar to the previous case, let's say the center of the big circle, the green circle is right here. Let's call this C1. Okay, not drawn to scale, obviously. And let's say the circle of the center of the red circle is right here, C2. Now, what's the story here? The story here is this, that if let's say the distance between the two centers is equal to the difference of the radii. How so? Here's how. So this, as you can see, is R1. This, as you can see, is R2. Now, taking the difference will give us the distance between the two centers. Okay? So let's write this down. Like I said, these are rules that you have to memorize. If the distance between the two centers is the same as the difference, okay, that's the only difference here, difference of the radii, the circles touch. Let's write this again. So if C1 is equal to R1 minus R2, once again, we're talking about the absolute value, the circles touch. Okay? All right, let me answer a few questions. Sir, can you do the topic circle theorems? Okay, if you're talking about math, I have already made a lot of videos on it, although I do intend to do it again. But if it's urgent, you can watch some of my old videos. So in my midterms, only few topics are coming, which are mostly P1 topics, such as vectors, transformation. However, there's both P1, P2, meaning calculator and non-calculator paper. Just solve past papers. Solve past papers. If you're an IGCSE student, then do O-level math paper 1 for practice. And do IGCSE specimen paper also. Okay, now the third and the final possibility, that is intersecting circles. Okay, how to tell if two circles are intersecting? Here's how you tell whether two circles are intersecting or not. So here's one circle, here is another circle. Okay, so we can see that the two circles are intersecting. Now, how do we tell whether they are going to intersect or not? Here's how. So this is the center of the first circle. This is the center of the other circle. If we join the two, this is what we get. Now, this, let's see. This is R1 and this is R2. As you can see, AB, or the distance between the two centers, is clearly less than the sum. Okay, if I add the two radii, this will be greater than the distance between the two centers. That's how you tell whether the two circles are intersecting or not. Okay, so if the distance between the centers is less than the sum of the radii, the circles intersect. Okay, circles intersect. Long story short, if C1, C2 is less than R1 plus R2, the circles intersect. Now, these are your important parts. Okay, so I would suggest that if you want to sit down and memorize, this is what you should memorize. This, and the two rules above. These two rules. Okay. Yeah, these are newly added to the syllabus. This is part of coordinate geometry of the circle. Okay. Now these rules, if you just look at these rules, they may seem a little complicated, but they are actually not that complicated given that you have them memorized. The questions, so far, the questions that I've seen are pretty straightforward. Now I'm going to solve a few questions from the worksheet, which I have already shared with you guys. I would suggest that you guys also download those questions, okay, as in download the worksheet. So just give me a minute. Let me open it up here. Just a minute. Inshallah, tomorrow, yeah, it is common sense, in case it's good you feel that way. Tomorrow, inshallah, I'll be doing a stream on mensuration of math. And then the day after that, probably AS. And then probably A2. Let's see. Let's see how things go. Okay, so here's the worksheet. I've attached it in this PDF. I'll upload this PDF as soon as the class ends. Sir, can you give us some tips for paper 1, which will be no calculator? Do the two specimen papers that you have. And then as far as the previous papers are concerned, there are a lot of questions, especially questions like logs, quadratics, some questions of polynomials. In fact, most questions of polynomial where you don't end up with, where you don't have to use the quadratic formula. In these questions, coordinate geometry also, in these questions, you don't have to use the calculator. So when you're practicing previous past papers, although I am working on a practice worksheet for non-calculator, basically a non-calculator practice worksheets. I'm working on those. I'm working on those as we speak. Hopefully, they'll be ready after the winter break. But before that, I would suggest when you're practicing past papers, limit the use of calculator as much as you can. Simple. Okay, so let's do a few questions so we can see how things really work over here. So here's a question. It says, prove that two circles, let's copy this. Prove that there are two circles, they touch each other, and state the coordinates of the point where the two circles touch. Okay, so let's add a new page here. Let's solve this question here. Okay, how do I prove that these two circles touch? Let's see. First of all, what do? We find out the center and we find out the radius. Okay. Now, as far as the first question is concerned, as far as the first equation is concerned, x squared plus y squared equals to 25. Now, the center here is 0, 0. Okay, and the radius here is 5. Okay. Now, then let's talk about the second equation. Now, as far as the second equation is concerned, we will have to find out the coordinates of the center by bringing it in completed square form. So, plus y square minus 18y, and then plus, let's take the constant across the equals to sign. So, let's leave a bit of space and let's write down the constant, which is minus 125. Okay, now what do we add? We add 12 square on the left hand side and we add 12 square on the right hand side, and then we add 9 square on the left hand side, we add 9 square on the right hand side as well. This becomes x minus 12 the whole thing square. This becomes y minus 9 the whole thing square, which is equal to what? Which is equal to minus 125 plus 144 plus 81, which is equal to 100. Okay, so what are the coordinates of the center? The coordinates of the center of this circle, which I'm going to call C2, are 12, 9. Okay, now what about the radius? Let's call this R1. The radius of the circle is 10 units. Okay, now how do we prove that these two circles touch? How do we prove that these two circles touch? Here's how we do it. We first find out the distance between the two centers. Okay, C1, C2. How do we do that? We'll have to use the quadratic so the distance formula. It's going to be 12 minus 0 the whole thing squared plus 9 minus 0 the whole thing squared. So 12 squared is 144, 9 squared is 81. If you add the 2, that's 225, square root of which is 15. Okay, so this is the distance between the two centers. Then if I add the two radii, what do we get? We get 5 plus 10, which means the sum of the two radii is equal to 15. Now, if we go back, this is the kind of situation where we are in, where the distance between the two centers is equal to the sum of the radii. Okay, the distance, I repeat, the distance between the two centers is equal to the sum of the radii. Therefore, the circles are touching. Okay, so here we are. Let's write this down. So what do we say? Here's what we say. We say that C1, C2 is equal to R1 plus R2. You can write it down in words also. Therefore, the circles touch. Now, another question. How will I find out the point of intersection? There's a pretty standard rule for finding out the point of intersection. How do we do that? Simultaneous, that's correct. So let's solve them simultaneously. Okay, it's a 6-mark question. So x squared plus y squared equals to 25 is one equation. The other equation is, let's use the expanded version, which is x squared plus y squared minus 24x minus 18y plus 125 equals to 0. So if I make x square the subject, no need to even make x the subject, just make x square the subject. Okay? Then we can plug it in, but we'll run into a problem. We will run into a problem if we try and solve it simultaneously. What's that? How will I find out x? Basically, we'll run into, actually we can fix that. We can change it to, we can fix that. I just realized, but let's see if there's an easier way. Don't you think there's an easier way? Shouldn't there be an easier way to find out the point of intersection, don't you think? There is actually an easier way. I'll show you what the easier way is. An easier way, let's not completely rule this out. Okay, what we can do is, we can actually write it like this, x minus 12 the whole thing squared. Even if we do write it like this, actually we will not be able to solve it simultaneously. Even if I use the completed square form, I will not be able to solve it simultaneously because we have x squared here, and here we have x minus 12 the whole thing squared. So solving them simultaneously to find out the coordinates of the center is not a good idea. Now what's plan B? What is plan B? Can we square root them? Okay. That still won't work. Now, remember, whenever you're solving equation of circle or anything to do with coordinate geometry, here's my suggestion. A good idea is always to make a rough sketch. Okay, making a rough sketch is something that will definitely save you. If you can't figure out what needs to be done, let's make a rough sketch. Okay, so here's one circle. This is the circle which has center 0, 0. Okay, and the radius of this circle is 5 units. Now we know that the other circle has radius 12, 9. Okay, we know that the radius of the other circle is 12, 9. That means where will I find out the other circle? The other circle which has radius 12, 9 it will be found somewhere over here. So this is the, sorry, not radius 12, 9, the center 12, 9. That means from the center of this circle, we will move 12 units to the right. Okay, we'll move 12 units to the right, and we will move 9 units up. Something like this. We will move 9 units up. That is where we will find the radius, the center of the circle. That means the other circle, the big circle, is going to be something like this. Not drawn to scale, obviously. Okay. So these are the two circles that are touching. Let me redraw it actually. So let's say this is 12. Okay, let's say this is 12. And then how many units up do we have to move? We have to move 9 units up. Okay, so this is where we will find the center of the big circle. Okay, this is C2. Now, what do we have to find? We have to find out the point of intersection. Okay, what do we have to find out? We have to find out the point of intersection. Now, what if, let's write down the coordinates first, 12, comma 9. What if I join the two centers and I make a straight line? What if I join the two centers and make a straight line? Okay, will I be able to find out the equation of this line? What do you think? You think I'll be able to find out the equation of this line? Line C1, C2? Yes or no? Yes, we will be. And where is this line intersecting? This line is intersecting the circle at the point where the two circles are touching. Okay? How did we figure this out? By making a rough sketch. If you don't make a rough sketch, God help you, you can't figure it out. Okay, so making a rough sketch is very important. That is why I think I mentioned it multiple times in the previous stream as well. Make a rough sketch. That will probably open your eyes and tell you what you have to do. So we can find out the equation of this line, and that will give us the point of intersection. Okay. Now there is another way. First, let's do it like this. There is another way, and then the other way is something that I don't think a lot of students will be able to identify. I mean, I'm not saying that in a bad way. It's something that it doesn't click to a lot of students. But first, let's do this. Let's find out the equation of line C1, C2. Okay, so we need 2 points. We have just the right ingredients, 0, 0, 12, comma 9. The gradient would be 9 minus 0 over 12 minus 0. So 3 upon 4. There is no y-intercept. The y-intercept is 0, so that means the equation of the line is y is equals to 3 upon 4x. So this is one equation. Solve this with any one equation of the circle. Now I would suggest you pick the easier one, pick the simpler one, so you don't have to do a lot of working. Plug it in here. So we have x squared as it is, plus 3 upon 4x, the whole thing squared equals to 25. So x squared plus 9 upon 16x squared equals to 25. When you take the LCM and you solve, I'll skip a few steps because I'm running out of space. So you will have 25 upon 16x squared, which is equal to 25. You cross out 25, x squared is equals to 16, which means x is equals to plus minus 4. But which value are we going to go with? Although we're getting plus and minus 4, which value are we going to go with? Are we going to go with positive 4 or negative 4? Mathematically, we're getting plus minus, but we can see that it can only be positive 4 right here. Okay, the point of intersection must be a positive value. Now, how do we find out the y-coordinate? We find out the y-coordinate by going back to the equation. It was y equals to 3 upon 4x. Now that we know what x is, we know that y is equals to 3. So there you go. We have the x-coordinate as well. Now, I know this is complicated. This is actually a past paper question from the specimen paper. Okay, this is actually a past paper question from the specimen paper. So in scenarios like these, it's not possible to solve simultaneously. It's actually not possible to solve equation of two circles simultaneously. I don't think you guys have ever done that. Even when you guys do simultaneous equations, at no point do we learn how to solve equation of two curves simultaneously or equation of two circles simultaneously. Okay, so I hope this is clear. Let me answer a few questions now. Walaikum salam. What advice do you give on studying for accounting? Should you disturb your own study schedule and study for amazing? See, there is no one size fits all. Just do, for mid-year, I would say, do yearly past papers as much as you can. As far as schedule is concerned, I don't think there is a golden schedule. It depends. Identify what are your good hours, what are your bad hours, what hours you think you're most attentive. Follow that, and don't make midterms a really big deal. It's important that you do well in them. Okay, I think especially students who are applying abroad, it's very important that they do well in them. And even students who are not applying abroad, students who are applying to good colleges should do well in midterms, but it's not the end of the world. If your own study schedule is on track and things are working well and you are well on track to get a good grade for CIE, then I would suggest you stick to that and take out a few hours to study for mid-year also. Okay, don't completely neglect your mid-years. But then once again, it's all relative. What might work for you may not work for someone else, and vice versa. So just long story short, just keep studying. Don't look for the perfect strategy. Just keep studying. Simple as that. Okay, what's your question, sir? Can you tell me which topics of advanced and A levels concepts were the same so I could watch them? Binomial, APGP, coordinate geometry, and circular measure. Binomial, APGP, coordinate geometry, circular measure, quadratics, and that's about it. Yeah, that's about it. Okay, so that was one question. Now, this was a very difficult question, but the good news is it's all downhill from here, because what I solved was actually a difficult question. The rest of the questions that you will come across are actually fairly easy. In the end, just don't forget to give your answer nicely. It's 4,3. Okay? All right, let's do more questions, shall we? Let's do this one. Show that the circle x square plus y square equals to 25 lies inside the circle. X square plus y square minus 8x equals to 84. Let's see. No, there is no vectors in A-level math, and there is no polynomials. There is vectors, but vectors is in P3, not AS math, and the concepts are not the same. And polynomials, if you're comparing P3, then yes, polynomials is also very similar to A-level math. But I would suggest you don't watch A-level math lectures for polynomials, you watch at math lectures only. Oh yeah, there's a different method also. Different method, okay. Different method is similar triangles. When will you do binomial distribution? I will be starting AS streams inshallah this week only. So I'll start with P1. Then somewhere along the way I'll do binomial distribution as well. So the other concept is, like I said, is called similar triangles. Okay. Now we know that the distance across the two radii, across the two centers is 15, and we know that the radius of the small circle is 5 units. Okay, so this is 5. Okay, and like I said, we can use similar triangles. So these two triangles are similar. These two triangles, the one in green and the one with black hypotenuse and the one in blue with black hypotenuse. Okay, how does this work? Here's how this works. So this length which is 12, okay, 12 divided by this length, whatever this is, let's call it x, is going to be the same as 9, or is going to be the same as the ratio of the hypotenuse. So what's the ratio of the hypotenuse? The ratio of the hypotenuse is 15:5. Now if you cross multiply, you will get x equals to 3. That means, sorry, wait a minute, I think I've done something wrong. 12 upon 3. Just a second. Okay, no, never mind. Let me see if this method actually works. Just a second. It is add maths, I know. Oh yeah. Never mind. So here's the alternative method. This is 15 and this is 5. So that means the hypotenuse of the smaller triangle, is 1/3 the length of the hypotenuse of the bigger triangle. Okay, I repeat. The hypotenuse of the smaller triangle, which is 5, is 1/3 the hypotenuse of the bigger triangle. Okay, now because these two triangles are similar, that means every length will be in the same ratio. That means this length, x, will also be 1/3 of the bigger length, which is 12. Therefore, x is equals to 4. And then this length will also be 1/3 of this length. That means let's call this y. So y will be equal to 1/3 times 9, which means y is equals to 3. And now you can see, because we have x equals to 4 and y equals to 3, and we're starting from 0, that means if I move 4 units right and 3 units up, we will have the coordinates of the center, coordinates of the point of intersection, which is 4 comma 3. But I do not recommend this method. In fact, I'm going to erase it. Like I said, it's not going to occur to a lot of students, and then students start feeling inferior if they're unable to, you know, figure something out. So I would suggest that you stick to the previous method. Somebody asked, that's why I explained it. Now let's come back to this question. Okay, question number 2. Show that the circle x squared plus y squared lies inside the circle. X squared plus y squared minus 8x equals to 84. Okay, so x squared minus 8x plus y squared. Okay, no need to add or something, anything over here, equals to 84. Now, what do I add on the left-hand side? I add 4 squared. That means I add 4 squared here. So we have x minus 4, the whole thing square, plus y squared, which is equal to 84 plus 16, which is equal to 100. Okay, now, the coordinates of the first circle are 0, 0, and the radius is equal to 5. The coordinates of the second circle are 4, 0, and the radius is equal to 10. Now, how do I show that the circle lies inside the circle? How do I show that? Let's see. That means they are non-intersecting circle. Okay, lies inside the circle means that they are non-intersecting. Okay. Now, what happens when two circles are non-intersecting? Let's see. Let's quickly, if you forget, make a rough sketch and you'll be able to figure it out. So here we have two circles that are not intersecting. Let's say this is the center of one circle, this is the center of the other. So the distance between the two centers is less than the difference of the radii, r1, r2. Okay, so the distance between the two centers must be less than the difference of the radii. If that is the case, that means the circles are not intersecting. Okay, so let's find out. C1, C2, let's find out the distance between the two centers. That would be 4 minus 0, the whole thing square, plus 0 minus 0, or simply 0 squared. So 4 minus 0 is 4, square of which is 16, square root of which is 4. So the distance between the two centers is 4 units, and the difference between the two radii is equal to 5 minus 10. Remember to take the modulus of it. So r1 minus r2 is equal to 5 when taken the modulus. And there you go. You can see 4 is less than 5. Therefore, the circle x square plus y square equals to 25 lies inside. There you go. Okay. Now let's do one more question. And then the rest of the questions I would suggest you guys can practice. They're fairly easy. I've solved all the difficult ones. Okay, I'd like you guys to do question number 4. Further math, I would only suggest that you take if throughout your life you haven't been troubled by any form of math. You haven't been troubled by add maths, you haven't been troubled by regular math, A-level math. Only then will I suggest that you take further math. No, I did not take further math. I took sciences. I took sciences in A-level math. Inshallah, there will be an A stream on Thursday or Wednesday. No, actually not Wednesday, Thursday or Friday. Okay, do we have an answer? No, I don't teach further math. Okay, I'll solve this. So the coordinates of the center of the first circle are -7 and -2, and the radius, let's call it r1, is equals to 2. The coordinates of the center of the second circle, let's call it C2, are -7, 4, and as far as the radius is concerned, that's equal to 4. Okay. Now, how do I show that the circles touch? Either the distance between the two centers is equal to the sum or the difference. Okay, one of the two. So let's first find out the distance between the two, sum or the difference of the radii. Okay. So -7 minus -7, the whole thing squared, plus 4 minus -2, the whole thing squared. Okay, let's see what do we get. So we get the following. -7 minus -7 becomes -7 plus 7, which is equal to 0, and 4 minus -2 is 6, square of which is 36. Then once again, when you take the square root, that's equal to 6. And we can see adding the two radii will give us 6 as well. Okay, so because 6 is equals to 6, therefore the circles touch. Now, whether they touch internally or externally, okay, this is something new. Do they touch internally or externally? Now, let's see. We have one circle here, and we have the other circle over here. If let's say that they were touching internally, then then the difference would not have been equal. Okay, then the sum would not be equal to the distance between the two centers. The difference would have been equal. But because they are touching externally, that is why the distance between the two centers is equal. So this is R1, let's suppose, and this is R2, let's suppose. This is C1, C2. So here you can see the only way for them to touch is to touch externally. So here we say externally. Okay, so there you go. That's the answer. Now let's see if we can do another question from the worksheet. No, I think that's enough. Okay, so this was a small topic. This was a continuation of the previous stream, and I hope you guys have understood it. I'm gonna keep this till here only. Let me know. I will probably run a poll on my Instagram. Let me know what topic you guys want me to stream next. I was thinking maybe APGP or binomial, one of the two. Let's see. So you guys can let me know on my Instagram. Okay, I'll probably run a poll, or maybe I'll just ask and you guys can tell me exactly what you want me to stream next. Okay, so I'll stop here. Wednesday, inshallah, I will be streaming trigonometry. Okay, do let when I post on my Instagram, please make sure that you guys give your feedback there. Okay, so no, not tomorrow. On Wednesday, I'll be streaming mensuration of math, IGCSE and O level, and Thursday is AS. Probably Friday, or maybe over the weekend, I'll do another ad math stream. Okay, so I'll stop here. See you guys. Good luck. See you guys soon, inshallah. Good luck to those who have their exam soon. Take care, everyone. Allah Hafiz.